Hey guys, today I'm going to teach you all about proportional relationships. By the end of this lesson, you'll be able to represent proportional relationships in graphs, tables, and equations. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So far, we've looked at proportionality in equations. So far, we've looked at proportional relationships in tables. We've looked at proportional relationships in graphs. So let's go ahead and review what we know so far. So let's start with the review. So proportional relationships represent a constant rate of change. In other words, that's the unit rate, what it's changing per something else. So it's a unit rate or a ratio. So proportional relationships represent a constant rate. It means it's a rate that stays the same. The next thing we know is that two things will be true about a graph that's proportional. The graph will be a straight line, and the graph will pass through the origin. So we know that a constant of proportionality is just the ratio or the unit rate representing that it's a rate that stays the same. We know when we look at that in a graph, it has to be a straight line that passes through the origin. So we see those on graphs as straight lines that go through 0, 0, the center of our graph. Those two things have to be true for a relationship to be proportional. Let's look at it in a table. This is just a review of tables. We want to check for equivalent ratios. So in other words, in a proportional table, if you divide any y value divided by the x value, it'll always be constant or the same. So this is a really good review of everything that we need to know about proportional relationships so far. Proportional relationships represent a constant rate of change, aka your unit rate. The two things that will be true about a graph is that it has to be a straight line that passes through the origin. And in a table, we want to divide any y by the x value, and we should get the same answer every time. So we should get the same ratio. So let's look down a little bit. It says the number of miles a white-tailed deer travels is shown in the table below. Complete the missing information and answer the question. So you're going to look at this graphic organizer. You have a table, a graph, a description of the situation, and is it proportional? Kind of an explanation. Then you have an equation in the middle that it all centers around. So this is how we're going to start looking at proportional relationships, because if we have a scenario like this, we have all these other things. We have tables, graphs, a description, and we have an equation. So what we're going to do starting out with is to fill out this table, because we have part of the information in the table. So we'll start by filling out the table, and then we'll just go around the world. So let's start with the table. Remember, in a table, I need to take all of the y values divided by the x values and get the same ratio. So let's go ahead and identify our y's and our x's. So in a table where it's like hours and miles, x would be on the left, y would be on the right. X is our input. It's what we put in. We put in hours to get out a number of miles. So the more hours go by, the more miles pass. And remember, this is about those white-tailed deer. So it's about the travel of a white-tailed deer. So off to the side, I'm going to take this y value, 84, and divide it by an x value, 3. So I have these in the table already. So I'm going to do y divided by x to get my unit rate. I got 28. So 28 miles per 1 hour. So I found the unit rate, 28 miles per 1 hour. So if I know that it's per 1, I can go ahead and fill that out here. 28 will be the first number. And then I want to do the same thing just to check here. 196 divided by 7 should also give me 28. So I'm just going to double check that. And it does. 196, our y, divided by our x, gives me 28. So if I do y divided by x for any point in the table, I should end up with an equivalent ratio, or the same answer. That would be our unit rate. So if the deer is traveling 28 miles per hour, I can fill out the rest of the table by taking that 28 miles per hour times each hour. If it's 28 miles per each hour, I can multiply 28 by 2, 28 by 4, 28 by 5, and so on to fill out how many miles that deer can go. So go ahead and take a second, pause the video, and fill out the rest of the table. This is what the rest of the table looks like. So we use this table to make predictions. For example, I know that if a deer is traveling at a constant rate, then I know that after 9 hours, it can go 252 miles. So that's the benefit of using a table. Let's go ahead and take what we know about this table and transfer it into a graph. So if we have a table, we also have a graph, and here's why. If we look at a graph, I know that there is an x-axis and a y-axis. The y is vertical, the x is horizontal. Over here, I have x points and y points. So all of these listed over here are actually points in your graph. If I wrote parentheses on either side and put a comma between it, you would see this as a point. So 1, 28 is an xy coordinate on your graph. Before we start plotting these points, I do want to just look at the graph right now. I want to give it a title, I want to label the axes, and I want to put a scale on it. So I want to put the scale of what it's going up by and over by. So we'll start with the x-axis. We know x is hours, so I can write hours down here. And then you get to decide the scale that it goes up by. So you get to label what each of these lines on the graph represent. It's going up by 1 each time, so to me this is pretty easy. Just go ahead and write 1, 2, 3, 4, and so on the lines. So I just went up to 9. You can decide your scale, but it should always start at 0. That's the origin. And then it goes up by 1 each time, so I just went up by 1. On the y-axis, it's going up by 28 each time. So I'm just going to go up by 28, and I'm just going to go ahead and list these on the side. So it should look something like this. Remember, y is our miles, so I want to write miles off to the side, make sure I'm labeling everything. It's really important that you keep this organized. And then the last thing we want to do is give it a title. We want to title our graph. I just called it deers miles per hour. So it's about a white-tailed deer and how it travels, how many miles per hour. So that's what I'm doing. So the rate that a deer travels is represented by this graph. And now that I have all of the axes labeled, I can go ahead and start plotting my points. So I look at the table for my points. So I'm back at the table. 128 is an XY coordinate. That's a matching pair. So I find 1 on the x-axis, that's here, and I go up to 28. When you plot a point, it's always x before y, walk before you fly. And it also comes before y in the alphabet. So if you're looking at it alphabetically, x comes before y in the alphabet, so you find your x point before you find your y point. You can label your points. I'm going to go ahead and move on to the next one just to give you an example, and then I'm going to let you do the rest by yourself. So go over 2, go up 56. So over 2, up 56, and I plot a point. The point should be on the kind of the grid line at the intersection of where the grid meets, and it should be a clear point. So go ahead and take a second to fill out the rest of the points on this graph, and you should start seeing that this is increasing at a constant rate. This is what your graph should look like. So it's increasing at a constant rate, which means I have a line through this. So I want to go ahead and put a straight line right through this, because remember, it's a proportional relationship. So it goes through 0, 0, and it's a straight line. So I've got a straight line I want to add. It's a line, so it does go on forever from that point. So we're going to put a little arrow on the end of our line. So if I was just given this graph, I could still find the constant of proportionality, or the unit rate, by looking at how many per 1x. So it's always going to be y divided by x. So I find the 1 on the x-axis, and that is going to tell me my unit rate. So right here tells me the unit rate. That is our constant of proportionality, 28 miles per 1 hour. So you can find that on a graph. And if I was just given this graph, I also know that this represents a proportional relationship because it's a straight line that passes through the origin. So using the table, using the graph, we can start writing a verbal description for this situation. It tells us in the word problem this is about the number of miles a white-tailed deer travels in miles per hour. We know that it travels 28 miles per 1 hour. So that is what we're going to write for our description. A white-tailed deer travels at a rate of 28 miles per hour, and I can see that in the table, and I can see that in the graph. So if I have a table, if I have a graph, I also have an equation. So let me go ahead and write the equation. We always start our equations in the form y equals. They're always going to start with a y equals. The miles equals 28 per hour. So we know that 28 is the constant rate. It will always increase by 28. So I want to write 28 here. The unit rate, or the constant of proportionality, is always next to our x. So when a number is next to a letter, that means multiply. It's 28 per hour, so that equals our miles. So that's what I have here. Miles equals 28 per hour. I've just used x's and y's to represent this in the equation. And the equation is just a rule for our graph and for our table. So let's look at the proportionality question. So this part of this whole roundabout thing here is just explaining how you know that this is a proportional relationship. How do you know that this whole example with the deer is proportional? For one, you have a constant rate of 28 miles per hour. That's your constant of proportionality, k. You have that as represented by the variable k. We have a constant of proportionality. In the graph, we also have a straight line. And we also have that straight line passing through the origin. So these are the things that make the relationship proportional. So this is just a graph, a table, and an equation representing this verbal description that a white-tailed deer travels at a rate of 28 miles per hour. And this represents a proportional relationship because it's a straight line that passes through the origin. So let's look at another example, except this time we have a verbal description, and it's written right here in the verbal description part. So we're going to fill out a graph, a table, and explain if it's proportional or not, and write an equation, all based on this verbal description. So if you want to take a second and try this all by yourself, pause the video and then press play when you're ready to check. Otherwise, I'm just going to walk it through with you. So it says, the Student Council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $7. So that is our unit rate, or our constant of proportionality. For each t-shirt, they'll donate $7. So it's $7 per one t-shirt. And I can write that as a fraction or a ratio, $7 per one t-shirt. So let's go ahead and start with the table. I like to start with the table. So we want to know what's going on here in the X column and what's going on here in the Y column. We know that these are X's and Y's because in a table, the X's are on the left, the Y's are on the right, just like in an ordered pair. We want to think about this like an input and an output situation. So what do I put in and what do I get out? Well, if I put in the number of t-shirts, as t-shirts increase, my money increases. So I get out money for each t-shirt. So the X one has to be the number of t-shirts. Remember, X has to be the number of t-shirts because I put in a number of t-shirts to get out a certain amount of money. So Y would be the total money donated. And again, if you weren't sure which one was X or Y, you could also look back at this rate here. It's always Y divided by X to give us our unit rate. So Y divided by X. Y is on top and Y is dollars. So let's look back at our table here. We know that it's 7 for every 1, but it starts with 5. If it's 7 for every 1, we can take that rate and multiply it by each X in the table. So 7 times 5 is 35. 7 times 10 is 70, and so on. It's increasing at a constant rate. I can always check this by taking any Y point divided by the X point, and I'll get 7. So you go ahead and take a second, and if you haven't already, multiply 7 by each one of the X's in this table. Pause the video and do that now if you haven't already. All right, now pause again if you need to take a second to check your table. All right, so this is a completed table. The table is useful because it shows us how we can make profit for how many shirts we can earn. So the table helps us predict and compare. So let's go ahead and look at this on a graph. So we want to look at it also, if we have a table, we have a graph. And a graph is just another visual way to look at a table. So let's go ahead and make sure that we have our axes labeled. This is always our x-axis. This is always going to be our y-axis. And we want to label, we know that this is the number of shirts because it's our x. We got that from the table. This on the y-axis is the dollar amount donated. I usually write this horizontally, vertically, I guess. I don't know, because it's easier to read. So that's the dollar amount donated. And then I want to label my scale. The scale is what each of these is increasing by on the graph. It's going up by 5s here. So I'm going to increase it by 5 on the x-axis. So mine's not too super pretty. It's just real quick and dirty, easy way to write this out. Just go by 5s on each line. Try to write as small as you can. And then over here on the y-axis, it's going up by 35 each time. I know that the unit rate is 7 for every 1, but since it's going up by 5s, it's going up by 35 each time on the graph. So the unit rate is still 7, don't get it twisted. But because we're showing it for every 5, we're going to go up by 35 for our scale on Y. So this is what my graph looks like with the axes labeled. Remember, one axis is an axis. When they're together, the plural is axes. I want to give my graph a title. So I'm talking about selling t-shirts to raise awareness for local animal shelter. For each t-shirt we sell, we'll donate $7. So I'm going to call it t-shirt donations. And then what I want to do now is plot all these points. So when I look at the table, I'm looking at a list of points. Each one of these in the table is a point. So you don't want to write the parentheses and the comma in it. That's just a way for me to show you, and you can if you want to, but that's just a way for me to show you that these are all points. So this is an X and this is a Y. So I go find 5 on the X-axis, and then I find 35. I plot the point by putting this dot between all the intersections of these lines. So somebody was wondering, is there a point at 0, 0? It has to pass through the origin, so is there a point there? The answer is yes. It's proportional because this relationship starts at 0. When we haven't sold any shirts, we also haven't made any money. We've not gotten any donations. So you can put a point at 0, 0, but you don't have to. It's implied. So we're going to continue doing this for the rest of the table. Go ahead and take a second. Plot the rest of the points from the table onto the graph. As you can see, it's increasing at a constant rate. In this table, we have it increasing by 35s, but we know that the unit rate is actually 7. Before we do that, let's go ahead and make sure we have a line through this, get a straight edge, and plot you a line through these points. Okay, so you should have a line that is increasing at a constant rate. It goes through the origin, and it's a straight line. So now, what I want to just point out is that in this graph, if we were given this graph first, you would be like, what's the unit rate? Because there's no per one. So here's how you find the unit rate from a graph. Please pay attention to this. I could take any point at all. Let's say this one. This point is 40, comma, 280. So over 40 up to 280. For any point on your graph, if you take the y divided by the x, you should get 7. And that's true. 280 divided by 40 is 7. That's our unit rate. The same thing goes if you pick any other point, 35 and 5. 35 divided by 5 is 7. So our unit rate is still 7. It's a constant rate because it's a straight line that is increasing at a constant rate through the origin. The equation for this table and this graph and this scenario is always going to start with a y equals. We're always going to start with that y equals. The total amount of money we make is $7 per shirt. It depends on the $7 that we spend or get donated per X, per shirt. X and Y are variables because it's changing. As you can see in the table, it's changing. As X increases, Y increases. There's no constant set amount for X and Y. The only constant is 7, our constant of proportionality, or the unit rate. So these three things show that this whole thing is proportional relationship. One, we can write a table, a graph, an equation for it, and it makes a straight line through the graph that passes through the origin. The ratio of all the y's divided by the x is 7. And this rule, or this equation, works for every point in our table and our graph. So in the verbal description, we found that $7 per one shirt is our unit rate. If it has a unit rate or a constant of proportionality, it is proportional. Take a second and try these practice problems by yourself. There's only 5 of them. Try it. Tell me if it's proportional or not. And if it is, write the equation represented. We'll go over this in class. All right, guys, that's it. If you made it to the end of this video, please put in the comments your favorite type of cereal. Today, we learned all about proportional relationships. So now you should be able to represent proportional relationships in graphs, tables, and equations. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.